Hi everyone, welcome to Cloud Lunch and Learn. Today we've got a session entitled Applying Data Science and Machine Learning using Microsoft.NET with Praveen. So because we've only got an hour and Praveen has a lot of awesome content to get through, I'm going to hand over to Praveen. If you've got any questions, please pop them in the chat, but we will probably get to them at the end. Over to you, Praveen.
Thank you, Lisa. Good morning, good evening, everyone. I would say it's like Chakno Nama in Iris. I'm not familiar with this language much, but I tried to say good evening in that language. And so my name is Praveen, and today I'll be speaking about applying data science and machine learning using Microsoft.NET technologies. So let me get started with my slides. So a little introduction or background about me. I'm working as a cloud architect at Harman. It's a Samsung company. We are into audio video control domain. And my area of expertise is mainly into cloud and distributed computing. And recently I have got an interest into artificial intelligence, machine learning, and for the past few years I've been working on cloud and IoT. And my base location is Bangalore, India, and I'm a member of .NET Foundation as well. So before I start, I'd like to acknowledge few people and few institutions. So first one is John Hopkins University for the data set that they have provided for COVID-19. Second one is Akshay SB. He has written a notebook in Python for which there is a COVID-19 analysis that has been done. So I try to refer that thing in .NET. So I'd like to acknowledge him for that. And the organizers, which is like Cloud Lunch and Learn, especially Hugo and Lisa for organizing such a great event, and which the event which is now kind of a global, it's not specific to some region. And last not the least, but the sponsors, which is Microsoft, Cloud Family, and .NET Mafia. So I have a quiz, a little small quiz. So what we need to do is you need to identify the language and type it in the chat window. This will be easy for you guys. Maybe you can type in your answers in the chat window.
Does anybody want to guess?
You can guess. No, it's not Indian. It's Irish. Correct. Okay. This one?
German.
Great. This is a little hard to you. Oh, correct, Mike. So it's ohayou gozaimasu in Japanese. And this one, this may be a little difficult.
Sanskrit?
It's very near to that one. Yeah, it's a Sanskrit, or you can say Hindi. It's from India, but you are very near to that one. Awesome. So these all words mean good morning in different languages. So the problem is we have different languages where the pronunciation varies, where the text varies for a same word. So, but the good part is like across the globe, we have one standard language called as English, through which we can communicate to each other across the globe. So So the challenge becomes if you know one language, it becomes difficult for you to learn the other language and get adapted to that one. So same is the case with the programming languages nowadays. You have a lot of programming languages present in the world. For example, you have C Sharp, JavaScript, Python, R. So you may be an expert in one or two languages, but getting your hands dirty or getting yourself acquainted with other languages, it becomes really a challenge. And most of the time goes into learning the language rather than solving a business problem. If you try to solve any problem, for example, if you want to learn data science or machine learning, most of the things have been done in these two predominant languages, which is Python and R. And for a .NET developer who comes from a C Sharp or F Sharp or VB.NET background, it becomes a challenge because the syntax is quite different in these two languages. Even the person who's aware of Python, he finds it little difficult to grasp the things that is present in R language. Same is the case for the .NET developer. So the till now the .NET developers, they have, in order to jump into the field of data science or machine learning, they had to learn either Python or R. Whereas people generally prefer Python because of the easy syntax that it provides. But moving from one language to another language becomes a barrier for them to solve the business problem that they have to do using the new technologies such as data science and machine learning. So basically, what is data science and machine learning? So today I'll be covering two parts of these two things. So from the data science perspective, I'll be covering the exploratory data analysis, and from the machine learning part, I'll be covering the prediction part, which is done using a time series analysis. So as per Wiki, in statistics, exploratory data analysis is an approach of analyzing data sets to summarize their main characteristics, often with visual methods. So another definition could be like a statistical model can be used or not, but primarily EDA is for seeing what the data can tell us beyond the formal modeling or hypothesis testing task. For example, you have the data, you have a CSV file which contains a lot of rows and columns, but if you just look into that one, if you just glimpse into that one, you'll not be able to understand the what is happening in that data, because it's kind of a raw and an unstructured data. So in order to make more predictable or more meaningful decisions out of that data, you have to transform that data into some kind of a visual information, which can be of like a pie chart or a bar chart or those kind of things that can help you how your data is looking, and you can make a better business decisions out of that one. So exploratory data analysis, as the name itself suggests, the exploratory, you need to explore the data and get a meaning out of that one using visualizations. So this is about exploratory data analysis. So another example could be like if you want to buy a house, so what all things you will consider? You will not go and just look at a house and buy it. What you need to consider is you will see what are the number of bedrooms are there, what type of house is it? Is it an apartment or is it a villa? And what kind of a locality is that? And what is the crime rate? So these are some characteristics or features which you will be looking into in order to make a judgmental decision for buying a house. So if you are given a data of these things in a CSV, you will not be able to do that one. But if you transform that tabular data into some visualization, you will be able to make better decisions, and that may lead a better buying of a house. So generally in Python or R or similar kind of data science platforms, what you would use is the data frame as an object. So data frame objects allows you to hold the features or the elements present in that data. So it is nothing but a tabular data which comprises of your rows and columns, wherein the columns represent the features present in that data, for example your name, age, designation, and rows represent the values of those features for a particular instance. So this is how you can correlate directly with a CSV or Excel sheet where you have the data present. And now when you uh, load it into a data frame object, either in Python or R or some other platform, the meaning remains the same. The whole data set will be loaded as a in a tabular way in a data frame object. Now, second thing I'm going to cover is the machine learning. So the way machine learning works is, for example, you have this picture and you have been asked to identify what is this. So you looking at the features of this, you will say it's a fish. Then how about this? So you will again you will be able to easily recognize and identify what object is it. So you will say, okay, it's a fish again. Then this, you will again say, okay, it's a fish. And what you do is you feed in this whole data to your machine, and machine will give an output and saying that it's a fish. And it the way it does is by identifying the features. For example, if you look at this picture itself, it has a eye, it has a tail, it has fins. So those are the characteristics of a fish. So the shape may vary. So some places it is oval in shape, some places it is circular in shape, but the main features of a fish are present, and based on that you are able to make a decision that it's a fish. So when you give a new fish which is of a different shape, now it is, you can see it's a semicircular shape, but you see that there are some known features which the machine has already learned. For example, if there is a tail, if there is an eye, if there is fin, then it will be a fish. So based on that understanding, the machine has learned something on the based on the past data. And as a result of that one, if we feed in a new type of data which is very much similar to that one, in that case we will get the system will say it's a fish. It will be able to predict it very well. So machine learning is like computers to program themselves. Herein we ask the computer to program to come up with an algorithm. So there is an analogy on this one. If programming is automation, then machine learning is automating the process of automation. For example, if you look at this one, the left one, or the traditional programming, wherein we feed in a data and we feed in a program. So and the computer does some crunching on that one, and it gives you an output. So for example, if your data is two numbers, for example it is like 2 and 3, and the program is addition. So you feed in the number 2 3 and you feed in the addition function to it, so the output will be 5. So this is what is being used in traditional programming, wherein you have to define the program or the algorithm. Whereas in machine learning, you feed in the data and you know the output. So for example, here if you give 2, 3 as the input and you give this output as 5, you feed into the computer, and the machine learning engine, what it will do, it will take those input and output, and based on the some characteristics, like if I add these two, I'll get 5. If I subtract, I'll not get 5. So in that case it will try different combinations altogether, and it will tell you what is the algorithm. So program on the right side, the green color, will be your addition in this case. So this is the difference between a traditional programming and a machine learning. So there are some prerequisites of ML, and you can't apply each and every machine learning or data science to each and every problem that you have been given. Sometimes it may be like a overkill to that problem. So you need to identify and analyze what is the problem statement you have been given to solve. So like there should be a pattern that should exist. So if there is no pattern involved, then there is no point of applying the machine learning. For example, we saw the example of a fish where we saw it has a tail, it has a eye, it has fins. So those are kind of a patterns that we see. Okay, all fish will have, or most of the fish will have those things. So there is a pattern that is existing there. So a pattern should exist for machine learning application to be applied. Second one is it has to be a mathematical model or algorithm is unknown. So when you don't know the algorithm, for example, I just took the example of addition. So you have the input 2 and 3 and the output, you know, it's 5, but you don't know the algorithm. Okay, whether it you got it through addition, you got it through subtraction, or you got it through multiplication, you have no knowledge on that one. In that case, you should apply a machine learning methodology there, so that if you feed in a data with a similar kind of things, it will give you a algorithm such as addition. Then last but not the least, and it's very important for you to work, if you want to work in the field of data science and machine learning, you need to have lot of data, because you know the input, you know the output. The only thing that you don't know is the algorithm, and the algorithm works based on the data that you have provided. If there is not enough data, enough in the sense that means the algorithm is not able to make patterns out of it. If you just give a data of similar type also, then it won't be able to. You have to have a lot of data with varied nature. It should be of variety. There should be a variety of in the data. Next one comes the types of machine learning. So you have basically three types of machine learning. One is supervised, second one is unsupervised, third one is reinforcement. There are other types as well, but these are the basic or general ones that are considered to be type of machine learning. So supervised is where we have the input and we know the output as well. So in the machine learning language, it's called as labels, where you know the labels of your data set, or you know how what is your output there. For example, we saw it's a fish. Fish, we know when we are feeding a fish, we know it's a fish. When we are adding two things, we know the output, that is it is 5. And in supervised itself, there are two types. One is classification, the other one is regression. So classification is something where we just give two inputs. We give a defined, we have a defined set of outputs. For example, you have gender, male, female, like that, or you can have uh, so similar kind of things which we can classify. That for example, you wanted to have a number, so number can be from 0 to digits, sorry, digits. So digit can be from 0 to 9, 0 1 2 3 4 5 6 7 8 9. So you know only these combinations can be made. There is nothing like half 0 or half 1 like that. So that comes under your classification, where you have predefined set of outputs. Whereas in regression, the output can vary. It is discrete in nature. For example, you wanted to know the temperature tomorrow. So temperature could range from 0 to 100 or like that. You have no control over that. So it can be in decimal as well. So those kind of things where you don't have uh, the classified things classified, there the regression comes into picture. Second one is unsupervised. where you have the data but you don't know the output of it. So what machine learning engine does is it takes that data and it crunches it and it comes out with some clusters out of that data. So cluster, it can form different clusters based on the similar characteristic that uh, it finds while uh, crunching that data. So you can get a cluster of red balls, or you can get a cluster of orange balls based on the color, or you can get a cluster of banana, or so those kind of things. So it automatically identifies what are the similarities between those things and creates a cluster out of it. Last is reinforcement learning, which comprises of which works on error, and it gives you a prediction in the sense it for so I'll give you an example here. Suppose you have it's a autonomous driving, and the car goes and it stops, sees a red signal. So if the system predicts it's a red light, then, and if there is a red light, then means it has correct, and it will give a reward to that system and it will become more confident. Whereas if the signal is red and the system predicts it to be green or yellow, in that case the prediction is wrong. Then what the system will do, it will penalize with some value, and the prediction confidence will be lower. So that way, on every reward and penalty, the system will evolve and will become better on its own. Here we are not specifying to the system whether it's a car, a red light or a green light. So that was about the type of machine learning that we have. Now coming to the frameworks. So we have a lot of frameworks available in our ecosystem. For example, you have Cafe2. The most prominent are the TensorFlow, Keras, Scikit-learn, PyTorch, and so recently last year Microsoft released ML.NET. Uh, Previous to that one, people were using Cognitive Toolkit from Microsoft, which is also good, but there are pros and cons of using that one as well. So most of these frameworks support Python, but ML.NET is mainly focused for .NET developers, and it's mainly specific for C# and F# developers. So I'll be doing some prediction machine learning part of it using by doing a prediction using time series analysis. As you can see, this is from a COVID-19 data set, and it gives you a visual representation of how the number of deaths have gone for the past 5-6 months since January. So what is a time series analysis? The analysis of data organized across unit of time. So you need to take one feature and a corresponding timeline against that one. For example, in this case, we are taking number of deaths as a feature, and we are taking days as a unit of time. It helps you understand the past trends and plan for the future. So based on your past trends, you can plan for the future things as well. For example, if you look at the current plot, where you can see till March 22, the things were going not in a very, it was very much in control, whereas since March 22 it started to explode, and it started to rise with in an exponential way. So we can say if we were to predict further to this timeline like May 27, then it may give us a value that may go in an exponential way. So based on the past trends, we can make a future thing predictions and plan for it. So this is very helpful in terms of government agencies, private agencies, even at home, what are precautions you have to take. those kind of things are very helpful. And there are different types of time series analysis that are performed. You have trends. For example, there's a set of pattern in terms of the sales of a product. So you see a trend happening. It is going up in the month of February or March, going down in the month of June, July, like that. Then there is a seasonality based on the seasons that are there. For example, you get during Christmas, then during winter, New Year. So like those kind of things comes under seasonality. Irregularity is it what we saw just now during COVID-19. No one expected that such thing will happen, and this came as an irregularity where lot of business has been impacted, and they are losing their business. So this was kind of an irregular thing which was not never expected. Then the cyclic is you see a trend that is happening after certain interval of time. The same thing it repeats. For example, after 3 months the sale goes up, after 3 months the sale goes down. So that becomes like a cyclic trend. Now we talked about till now about data science and machine learning. What are these? But we need to understand why we are going with the .NET today. Why we can't go with the Python itself or R, learn those languages. So we can learn those languages, invest our time, get up to solve the business problem, but the learning curve is quite steep there. So it really becomes a challenge. Rather than focusing on solving the business problem or understanding the algorithm, the most of the majority of the time will be spent in uh, learning the language or nitty-gritties of the language, for example, the Python and the R. So there are some reasons for that why .NET is coming up with great frameworks. So this is the slide I took it from last week. There was a .NET conference that happened globally, and according to this one, we have around 1.5 million .NET Core developers, and .NET Core is the most loved framework as of 2019 and 2020, and it is like a top 30 highest velocity open source projects, which comes under your .NET Foundation is one of them, which is catering to a lot of open source projects. And it is among the top 5 languages on GitHub. And this is very interesting that it is 7 times faster than Node.js. Compared to like Node.js, it's 7 times faster. And the people who are new to .NET are student, and that comprises of 40%. And the other benefit that we have for .NET is the Python language. Yeah, it may be very versatile, it may be having a lot of features and other things, but it still it has not gone into the enterprise world to the extent that .NET, Java, and Go has gone. So still it is struggling in that area, whereas .NET shines in that area. It is already being tested and used by a lot of enterprises. And this is about the adoption. So Visual 5 million .NET developers we have, around 1 million new Visual Studio developers, then 600K new active .NET Core developers in the last year, then 2 million .NET on Linux. So this is a pretty interesting thing that happened in the past few years, that .NET has gone open source plus cross platform. That was lagging behind the .NET. Now with this change, a lot of things have been changed in terms of the .NET ecosystem or the C# or the App world. Now coming to the solving the machine learning problems using .NET. So there is a framework called as ML.NET, which is from Microsoft for developing custom AI ML application. When I say custom, means you have a lot of control over that one. It's not like drag and drop or something like that. It was originated in 2002 as part of Microsoft research project. So you can say it's around like 18 years old, but project that was done by Microsoft, and uh, it is very well tested and used within the Microsoft. Only 2 years back, Microsoft only last year itself they have released the first version of it for the public to use. Now it is open source, and it has a current version is 1.5.1. So a lot of enterprises have started to use it now. So this is a where the usage of machine learning frameworks are being used. So if you want to use a create a pre-built AI or ready to use thing, then in that case you will prefer to use Azure Cognitive Services. Whereas if you want to build your own something, then in that case you will prefer to use ML.1 because it provides a deep level of customization compared to your Azure Cognitive Services. So as represented here on the slide, it's easier and having a less control on the left side. Whereas if you want to have a full control, then you should go with these frameworks, but it will be a little harder. But you get but in enterprises mainly you wanted to have more control. In that case it is more suitable for the enterprises. These are the characteristics of ML.NET. So it's a framework made for .NET developers specifically. You can build your own custom models by writing C# or F# code. It's developer focused. It provides just the right amount of productivity and control. It's very extensible. You can tap into other machine learning toolkits with the rich extensibility model like TensorFlow. So the good part here is it has a compatibility with a Onyx model, which is ONNX, which is a standard across many different machine learning frameworks. So what happens, so if you develop a machine learning algorithm in PyTorch, suppose, or TensorFlow, you can save it in Onyx format, and same can be utilized here. So you need not to reinvent the wheel, or you can need not to recreate those things which is already present. So in that case you can just use it and use within your ML.NET. It's very much proven. It has been used internally in products like Office and Bing for years, and it's open source and cross platform. It's very much proven at scale and enterprise ready. For example, you have Bing Ads, Excel, PowerPoint, Windows 10, Azure Stream Analytics. So Microsoft has been using it for the past 18 years. So they have been leveraging it quite well, and it's a well and tested framework. These are some possibilities that you can do. As of now, it has not grown, or it has not matured enough till the level of other frameworks, because recently it has been out open sourced in the last year. So possibilities such as sentiment analysis, issue classification, image classification, object detection, forecasting, predictive maintenance, recommendations, then customer segmentation. So these are some of the things possibility, but Microsoft has been working a lot on these things, and they have been actively adding new things to it. So this is a basic workflow of machine learning framework in ML.NET. You prepare your data by loading a data. You extract the features. You build and train. That means you train your model. Then you will evaluate if you are convinced with the performance of your model. Then you use it within your application. So application model consumption can be done on like a console app. It can be done on a web API project. It can be done on a Azure function. So there are different areas where you can just use it. So when you train a model and save, you can save a model, it will be saved in a zip file, which can be easily utilized in those platforms. This is a basic pipeline. For example, you load, so loading means you can load it from text, binary, file, enumerable. Then you transform, for example, your data is not in a proper format. For example, image is made up of pixels. So you need to load it into a pixel wise. Then you have a gender, which is a string, but computer doesn't understand a string. In that case, you have to convert it into a binary word thing, either 0 or 1, like those things. So those kind of transformations you can do with the transformation step. Then once the transformation is done, then you can train your model. So that means you will give it some data, it will crunch that data, and it will come up with an algorithm. So that algorithm is nothing but your model. So once you get the model, you will evaluate on new data which the model has never seen. So if it works well, then you take that one. If it doesn't work well, then in that case you retrain with the more data or do some more setting changes. And once it is done, you are convinced, okay, my model is performing good and with a good accuracy. Then you deploy it to your deployments, which can be your Azure function or ASP.NET Core application. So today I'll be applying this EDA and ML on COVID-19 dataset. So before we jump into that one, a little brief about the COVID-19. So it's a coronavirus 2019 is an infectious disease caused by severe acute respiratory syndrome coronavirus 2. The disease was first identified in 2019 in Wuhan, the capital of China's Hubei province, and has since spread globally, resulting in the ongoing 2019-2020 coronavirus pandemic. So everyone has suffered because of this one. The business are not doing great in that terms. So this is just a statistics about as on July 30, 2020. So you have 17 million confirmed cases and around 0.66 million deaths as of now. But if you look at this data, if you look at these numbers, you can't predict what has happened in the past. How was the transition that has happened? Whether it was linear, whether it was exponential, whether it was polynomial. So those kind of things you can't predict just by looking at the numbers. So in order to make these numbers more meaningful, we perform the exploratory data analysis, and there comes these charts. So now if you look at the same thing in a chart, you can say, okay, it has increased since March 22 or something nearby then, and it has been kept on increasing. There is no decline in that one. So this is a area of concern. So authorities, what they can do, they can take preventive actions, and they can put more restrictions so that it should not spread. But looking at this, we can at least say, okay, for the next, if we want to predict for the next 7 days, the plot will show a increasing trend. It won't be kind of a linear or a declining based on the past history that we saw we are seeing just now. Now we need to perform EDA using .NET DataFrame. So similar to Python, where we had the DataFrame, which is nothing but a tabular object. We also have something similar recently introduced in .NET. So what is a .NET DataFrame? It's a collection of columns. It's an in-memory representation of structured data. It's very similar to Python DataFrame. And what you can perform on a .NET DataFrame, you can load a data set from CSV. You can perform the row or column selection, what all columns to take, what all columns to remove, what all rows to take, what all rows to remove. You can join or merge two data frames. You can group by, and you can perform data cleaning, such as removing the null values. and machine learning using MLnet.net. So today I'll be using the time series part of it. There are different things we can do, but as we are mainly focusing on the COVID-19 data set, where we have a time variable and the number of confirmed cases. So in that case, I'll be using machine time series analysis. So it is done through by loading a data using a ML context. It's very similar to what we have a DB context. And so machine ML.NET provides a ML context for that. And we create a ML pipeline, and we will predict the confirmed cases for the next 7 days. And the algorithm that we are going to use is single spectrum analysis, which is present in ML.NET. So at present, only this is the time series framework library present in API present in the ML.NET framework. But I think the Microsoft team has been working very hard to add more and more things. For example, bringing up moving average precision, then ARIMA and other kind of time series algorithms into this framework. Now, you may see two things, so very similar things in DataFrame and machine ML.NET. So ML.NET has something called as the IDataView, which also represents a tabular view. So, but there are little bit of differences between those, which I have put it up in a tabular format. For example, DataFrame lies within your Microsoft.data namespace, and IDataView lies within your Microsoft.ml. DataFrame is very much analogous to list, which you can modify, you can add, you can remove the items in it. IDataView is kind of enumerable, which you can read, but you cannot modify. DataFrame is mainly for data science or exploration, and IDataView is for predictions or machine learning things. DataFrame is schemaless, so that means you need not to define any class for that one or a type for that one. Whereas in IDataView, it is schema bound, and you need to have a knowledge about the columns present in your CSV file or your data. DataFrame is eagerly loaded. That means it loads the whole data set into the memory, and IDataView is lazy loaded. So that means it loads whenever it is accessed. DataFrame is in memory. I just saw that one, said that one. Then IDataView is stream based, which is forward only cursors. So it is very fast compared to DataFrame. It is very memory efficient also. DataFrame has a random access because it's all in memory, so you can access any of the elements within your data frame, whereas in IDataView you need to go through each and every element for accessing an element. DataFrame being in memory, it's very easy to debug, whereas IDataView, it's a stream based, so it's difficult to debug. There is a limitation in DataFrame that it only supports CSV as of now, but there is a plan to add more to this one. Whereas IDataView supports CSV, IEnableable, and a relational DB. And for visualization, I have used a library called as Plotly, and I have used a bar chart of it, scatter chart, pie chart. And these are the charts that got generated. So this is from the data science or data frame. You can see number of confirmed cases, top 5 countries, and this is how the prediction was done. So this is on the left, you had the data till this date, and these 7 values are the predicted values, and this is the plot that comes. So if you look at the right, there is an increasing trend. Either there is a little decline because of the limited data that we have, but we can say okay, it is in accordance with the pattern that we saw in the past 7 days or past 15 days, which is like exponentially increasing. So our prediction is very much near to that one. So predictions are never 100% correct. They are very much near. It gives you a hint of how the things will be in future. So with that, I'll just jump into my demo. Let me.
Hey Praveen, we've got two questions. Do you want me to hold them to the end after your demo, or do you want pass them
I
now.
think.
It's up to you.
Let me check. I think I have hardly 8 minutes left, so I'll just rush up to the my demo. Maybe I'll be happy to take it afterwards.
Okay, no worries.
Okay, so you are able to see the screen?
I can see your PowerPoint.
Great. Okay. So this is maybe I'll just post it there in the chat. Okay. So this is the place where I have all the resources. It contains the deck. There is a 3-part series. There is a Jupyter notebook. There is a Visual Studio Code. All things are available here. The links are available for all those things. So I'll just quickly jump onto this is my local system. So yeah. So I have installed a Jupyter notebook, and there is something called a .NET Interactive, which allows you to have C# and F# kernel installed. So for those who doesn't know Jupyter notebook, it is one of the a great way to run your code and check it instantly rather than using a console application and other things. And I think till last year it was supporting only Python and R, but Microsoft also added C# and F# support to it. That made it very easy and to use. And okay, so this is how the Jupyter notebook looks like. You go to there. This is my IPython notebook. This is the acronym for IPYNB. And the way it is different from Python is you have this thing. Here you see .NET C#. Otherwise, if you take any Python one, it will have Python 3 will be here, and you can run your Python code. But now it supports C#, F#, even PowerShell also. You can run your PowerShell commands and see the output instantly. And it is a mix of your Markdown plus code running cells. So you can run your code, you can add your Markdown. So I'll just quickly go through this one. So this is nothing but your this is about the uh, exploratory data analysis. So what I have been doing here is, so this is how you okay yeah, so this is how you use import your install your NuGet packages like you do it in your Visual Studio. It's very similar, but the syntax is little different, and you get everything in one page. So I'm using Microsoft.ml and data.analysis and Plotly for charts. And the way you run it, you perform shift and enter. It goes to the next line. So you can see it is installing the packages. Okay, so it has installed all the packages, and this is normal your C# code. That makes it very cool. I have defined the constant, and this is a code to display your data frame object. So in the raw format, the display is not very intuitive. So in order to make it very intuitive, you have to format and put it some HTML code of it. So this is a code just for representing your data frame in a tabular format. So you do this. Okay, yeah. So here I am just loading it from the GitHub link of that John Hopkins data set. This is how the data gets loaded this is inside your CSV file. So the problem here was some of the values does have a comma. So if we load a CSV, it consider it to be a comma separated value. So this is broken. So what I did, I made a transformation, and I have changed this underscore this comma with the underscore. Now this is just for transformation. This is the actual code. So you have that data frame class and it has a load CSV, and here you specify the file name. So let me quickly go. So this is my file which has the data set. Yeah. So this is what I am loading here. Okay. And so this is what I'm loading, and so here you can see it has loaded and displayed it in a tabular format. So it says COVID-19 data frame. This has these many columns present: latitude, longitude, confirmed, death, recovered, active, combined king. So as you see now, I have changed that comma with a underscore. So this is just displays the if you, and this is like a print statement here in or console.writeLine, you can say, inside your Jupyter notebook for .NET C#. Displays used for that one. You provide an object, it displays that one. So currently it is, if you just provide this one, it will display the 10 records. Whereas if you want to see only the 5 records, top 5, you can use had. You want to see random 6 values, 6 rows, you can use a sample. Now this is very cool here. So description allows you to get the maximum value or the minimum value or the mean value for each and every column present. And this is info, means it gives you information about the data types present. Now once you have loaded the data set, you need to clean means you have to remove unnecessary things. So there are multiple ways of doing that one, but I'll restrict myself to one of them. So for example, first of all, I'm only concerned about these 3-4 columns. I'm not worried about FIPS, admin2, or last latitude, longitude. What I did, I'll just remove those columns from my data frame, and it comes like this. So you just have this much, and now you can play around with this data set. Now the other thing is removing invalid active cases. So as you can see, it has some negative value, which is quite suspicious. So because the way we calculate the active cases is, you have confirmed cases, you subtract the deaths in that, and you subtract the recovered cases. And but in this case it is coming negative, so we will see why it is coming. So what we will do, we will provide a filter on this column called as active, this one active. And what we will do, we will just take the values that are less than 0. So here we are using element wise less than, so this is for filtering, and this filter we put it inside your filter. So filter takes column name, column object, and based on the thing, it gives you the values. So if I do this, we can see all are negative, which is suspicious. For example, I have taken the index 5. So if you go according to this one, you have confirmed 10, you have deaths 51, and active as minus 41. So we need to remove such kind of data which is having a value for active cases less than 0. So what we do, we create another active filter which is having values greater than 0, and we will apply to our original data frame. So this is where we are applying it, and once we apply this one, you can see we have removed all that negative or suspicious values or illegal values. So this is about data cleaning. Now coming to the visualization, because without visualization it doesn't make sense to have this kind of thing. Yeah, so what we did is I have used confirmed cases, deaths, and recovered. So from the data frame dot columns, you get the confirmed, death, and recovered. You do the sum of those values and you just plot it. So this is a plot, graph.py. So here you provide the, for the pi you provide the values, which is nothing but your total confirmed, total death, and total recovered, and labels, which is confirmed, death, and recovered corresponding to that. And this is how so if you miss any cell or if you miss any execution, you may get an error also, so you can fix that one. So this is about that one. So it's very intuitive. You can see mouse over this one, and you can save also. You can toggle also. So there are a lot of options present here. You can see everything here inside this only. Now I wanted to see top 5 confirmed cases, countries with confirmed cases. So I'll again plot it. So this is for top 5 countries confirmed cases with deaths. This is the one, and this is the recovered. Now for India, I have just put it, and it comes like this. This is you can do for any country inside word. Then this is very cool here. You can have a map wherein you can show all those things. So what I did is I got the things as per the country. So based on the country, I'm getting it, and I'm plotting a map out of it. So it automatically generates your plot, the map with the color combination, and you can see mouse over this and see what are the number of cases here, there, anywhere. And it's very cool. You can zoom in, zoom out. You can take a snapshot of this. So this is about the data visualization or exploratory data analysis. Second thing is about prediction using time series analysis. So there, this is also very similar to that one. I'll directly jump into this is about you getting your NuGet packages, using statements, constant, then formatting. So this is the thing. Yeah, so I told you IDataView it is schema bound. So if you are doing any machine learning thing or time series kind of thing, you need to have a schema. So we need to have a schema which says confirmed data. That means it should have two things. One is time variation time thing, and one is the feature. So here I'm taking the feature as a total confirmed cases against date, and this load column specify what is the index of the column in your CSV. So in my case, 0 is the index for the date and 1 is the index for the total confirmed cases. So this is done. Then this is your for forecasting. So this is where you will hold the list of forecasted values. For example, I wanted to predict the number of total confirmed cases for next 7 days. So this float array will hold those values and it will give you that. Then this is just for representation I have done. It has nothing to do. So this is how we load inside your data frame. This is the same thing that I did. This is just to see how what all things are present in the data set. Tail is used to get the last 10 rows. Then description is the very similar to that. Then I'm just plotting it, number of confirmed cases over time. So if you see, this is the plot that is going up. So if we try to predict something, that means our predictions should also go up in a similar fashion. So this is the ML context that I was talking about, and we are specifying the CSV file here. We are saying that it has a header. That means there was a header present and the separator character was comma, and we are saying that it has to be in according to the schema that we have defined, that is confirmed data. This is about splitting the data set. Just generally it's a standard practice for a machine learning to split a data set into some ratio, for example 70-30 or 80-20 or 90-10, so that you train on one part of it and you test it on the other part of it. So I also did a same thing. I have a split ratio of I think 90. So I have taken 90% of my whole data set. So my whole data set contains 107 records. Out of that I have taken only 100, and this is your so training samples. That means I am taking out of 107, I am taking 100 for training. Series length is like how you divide your data into different chunks. So for example 30 you want to take at a time only 30. Window size, like for the past 7 days I'll use the data and use it for the prediction for the next horizon. So forecast period here is 7. That means I wanted to predict it for 7 days, next 7 days, and this is your main function. pipeline. So forecast by SSA, here you provide your input, you provide your output, column name, input column name, then window size, which is 7, then series length, then training size is number of training. Horizon is for how many days I wanted to predict. So once this is done, this is the main part. This is the algorithm from the ML.NET that does the magic. You take that one and you provide your data. So training data that you provide, the 100 rows that you provide to it. And once it has run over that one, you get the model. So in order to predict how good it has performed, you do a transformation. That means you do a evaluation on that. And evaluation can be done based on different parameters, such as different techniques such as mean absolute error or root mean squared error. Whereas mean absolute error is how close is your prediction to the actual value, whereas root mean squared error tells you it summarizes the error in the model. So there are different ways of it, and you create a matrix out of it and you display it. So once you think, okay, your model has performed quite well, you can save it. So this is the API for saving the model. Here you provide the model path and you see it gets saved as a zip file. So this is how the model gets saved. Now it can be used within your console application or a ASP.NET Web API project or a Azure function. So, but for prediction, we are using like this is the function for predicting, and we are predicting it for 7 days. And this is the important part of it. Like we are giving the test data, not the actual one. So we are predicting on the test data, and what it does, it predict the things, and once the predicted, the plot is like this. So that means we get a increasing trend, which is very similar to what we have in the past 7 days. So there is a difference here. The reason being because of the data that is not very huge. The data is quite less, but it is just to give you a hint or explanation that how the things work in ML.NET for time series prediction. So this analogy or this thing can be applied to any time series problem. And this is about lower bound and upper bound, which like this is the forecasted line, and this is a upper bound and a lower bound, which says that these are the maximum error or the minimum error which can happen for forecasting. So the wider the values, that means the forecasting is not good, whereas the narrow this thing is there, that means the forecast is quite good. So this is all about. I know I'm been rushing a lot because of the time constraint, and with that I'll just jump on to my slide with a couple of more things. Okay, so these are some companies that have been using ML.NET in production as of now. Okay, apart from Microsoft, and there is something called as a model builder, that is the AutoML. What it does, you just provide a CSV file to it, and it takes that one, it automatically trains it, does everything for you, and in the end you can do the evaluation, you can do the prediction, you can get the model saved, and plus you will get the code as well. So whatever I have written is not required if you are using a model builder, but the problem here is it's not very much customizable. If you want to customize, if you want to tune your parameters, you have to go with that other thing. So you can see here it is doing those things. And these are some references, and these are some resources. I already shared this thing. Maybe I'll say one more thing. Yeah. So this is something I have written in dev.2, and okay, yeah. So, and these are the ways you can connect to me if you have any questions or anything after this session. I'll try to answer it now itself, but if you further have any doubts or you need any guidance, you can just feel free to tweet me. Okay, with that, I'll just conclude it and I'll open the floor for questions.
Thanks, Praveen. We only had a few, so there was one here on deployment. Can we use either Azure FN or ASP.net core or both?
Please come again, Lisa.
So if you just scroll up a little bit, that one, there you go. On deploy, this one.
It's not mandatory. You can use it within your Azure function itself. So what you have to do, that model.zip file that we had, so you need to put it in your storage blob and access it from your Azure functions. So very much similar to what you do it in a console app. So you have to write the code to access the model.zip file from your storage. So it can be deployed to Azure function or ASP.NET Core. Anyway, you have to get access from the blob. I hope that answers the question.
Okay, awesome. I think there was just another one just down from there about accessing the data. And then the other questions were answered in the discussion in the chat. So I'll conclude the recording there. We can stay on the line if anyone has any questions. And then just to let you guys know, I've popped some links in the chat. So remember to register at the Microsoft Learning Materials link. I've also popped a link there to GitHub, where you can find the content from our speakers.
Yeah. So I just want to add on. Sorry to interrupt you. I just want to add on to this question which Emma has asked. So do you use ML.NET on Azure only, or you can use it on desktop? So the best part is it's pure desktop. You don't need any internet or anything. So what you can do. So I already have the code there in code also present here. So for example, this one. So this is a .NET solution which has the full code that I did for exploratory data analysis. There is a class that I have written. You can download it locally and run it. Then you have it for prediction also. So everything is there. So that makes it very convenient. You need not to have Azure subscription or any kind of thing just to validate your hypothesis of creating a prediction or data analysis on. It's very, very powerful in that way.
We've got another question just popped in right down at the bottom.
Okay. To which other programming model skill and FTF Keras would you compare ML.NET? That is, which other model is most like? So every framework has its own pros and cons. So I would say PyTorch would be very much similar to this one because PyTorch is mainly object oriented. You can write the code in an object oriented manner there, and .NET also you can write it. And I have used both of them, PyTorch, Keras, Scikit-learn I haven't used. TensorFlow, I find it a little bit difficult to grasp for a .NET developer. But if you are using ML.NET, if you are from .NET background or if you are from PyTorch background, you should be able to easily grasp ML.NET if you are from PyTorch or Keras background. I hope, Mike, that answers your question.
Awesome. Okay, I'm going to stop the recording now. Thanks everyone for joining us. Thanks Praveen for an awesome session. Much appreciated. And we'll see you all very much. Next Cloud Lunch and Learn. Thank you.
Thank you everyone for joining the session today, taking time. I hope it was very fruitful. Feel free to catch me over Twitter for any questions or for anything. I also run a ML.NET user group, Telegram group. if you want to be part of that one, the link is present in my slides. You can just feel free to join that one. And with that, I'd like to thank Hugo, Lisa, and the whole team who did an excellent job in organizing this great event. Thank you.
Thanks, Praveen. Much appreciated.
Thank you.